In this video, I'm going to take you through a new addition that I made to the Firefighter training wall prop. Now, if you're not familiar with the training wall, it's a prop that I designed and constructed quite a few years ago, and one that's become very popular. It's sent out well over 1,000 plans to firefighters and departments, literally across the globe. And as a result, I've received a lot of feedback from firefighters who have enhanced and improved on the prop. And that's always kept me thinking on what else I could do to make it better. Through the years, I made a few additions myself, including the basic window modification, the Denver drill hallway, and the latest one that I designed and constructed is the pitch roof attachment. Now, before we go any farther, I just want to state that if your department does not conduct pitch roof operations, you're not going to want to watch this video, because it's about exactly that. A prop that will allow you to train and practice various techniques for operating on pitch roofs, from basic maneuvers all the way to advanced firefighter survival and rapid intervention techniques. Now, if your department does operate on pitch roofs, and at the end of the video you're interested in the prop, feel free to send me your email address and I will forward you plans for the prop free of charge. Now, if I got your attention and you're still watching, here's what this video is going to entail. In the first half, I'm going to take you through the prop itself. Now, I'm not going to get too in depth because the plans that I would send you will cover it in great detail. So I'm just going to give you a general overview. In the second half, we're going to discuss and demonstrate the various techniques that you can practice on the prop. Before I take you through the prop, I just want to emphasize the fact that I don't have any background in architecture. I'm definitely not an engineer, and I really don't even have any professional carpentry experience. And that's my disclaimer, because anyone that does have experience in those fields could probably look at this prop and design it and construct it better. And if you can, by all means do so. It's something that I encourage anyway. However, if you're a novice like myself and you're looking for some reassurance, I can tell you the prop, as you see it, is very functional. It's easy to set up and break down, and it's safe to use. We've definitely put it through its paces and never had a problem with the tactics that we practice on it. So I feel confident that you won't be disappointed. So with that being said, let's take a closer look at the prop. When I first designed and constructed the Firefighter training wall prop, I wanted to keep it versatile. And what I mean by that is I want to have the ability to practice a variety of different techniques on it. But I also want to keep it portable and easy to transport. When I constructed the Denver drill hallway and now the pitch roof attachment, I want to stay within that concept. So with all three of those props, there isn't one component that's longer than 8 feet or wider than 4. So when you break the props down, you can put them in the back of a full-size pickup truck and pretty much take them anywhere. Now, the pitch roof attachment works in direct unison with the training wall prop. The top of the pitch roof rests on top of the training wall, while the base of the roof deck is supported by a separate bearing wall. Let's take a closer look at each one of those elements. The pitch roof attachment is comprised of two major components. You have the roof deck and then the bearing wall. Now, the roof deck is further broken down into two separate sections. Each section is 3.5 feet wide by 7 feet long. The decks are connected together with 4 half-inch bolts along with wing nuts and washers that are fairly evenly spaced along the center joint. When the decks are fastened together, you have a working surface of 7 feet square. Now, that may not seem like a lot, but it's plenty large enough for what we use the prop for. Each deck section is skinned with 3/4 inch plywood. The support structure is made from 2x6s, which act as the roof joists or rafters. They are configured in such a manner that allows the top of the roof deck to interlock with the top of the training wall prop. Now, on the deck surface, you'll see a series of holes. There's 4 smaller ones here, okay, 2 on each deck, and then 2 larger ones on each side. The larger ones here are used to practice a firefighter survival technique, placing a hook, an anchor hook with an escape system for bailing off a pitch roof. Again, we'll show you that in the demo portion. You also see that in the center 2 holes, we have straps. These are ratchet straps. I'm going to give you a little closer look at that on the other side of the prop. The ratchet straps are used to help compress the top of the roof deck to the top of the training wall prop. Again, it adds to a little bit more stability and makes the prop safer to use. These smaller holes are used for a pallet brace. Now, this pallet brace can be inserted on the left or right side. It's designed to hold a pallet on the surface of the roof deck. So when we're practicing cutting with a saw, it keeps the pallet in place. Again, you'll see a closer look at that when we get into the demo portion. Here's a close-up of that pallet brace, which is a 2x6 that's 3.5 feet long. Notice on the end we have 3/4 inch threaded pipe with an end cap that are held onto the 2x6 with C-clamps. And again, this is what's inserted on either the right or left side of the roof deck to support a pallet when we're practicing vertical ventilation or cutting with a saw. Here's a close-up of the ratchet strap assembly that I mentioned on the other side. Again, what it's designed to do is compress or sandwich the top of the roof deck to the top of the training wall prop. It's comprised of 2 ratchet straps, as I mentioned, that go through the center larger holes, and then a spacer block. The spacer block is just designed to take up space and give a point for the ratchet straps or the ratchets to actually leverage off of. It's 3 2x6s that are screwed together. They're 21 inches in length, so they fit within the 21-inch opening of the training wall prop, of the window. And these are a spacer block, a 2x4 on each side, which we typically keep in 80 to 85% of the time. Now, anytime that we change the roof pitch, we need to loosen up this assembly. So right now it's set at a 12-12. Get it all ratcheted down so it's nice and tight. If I'm going to change the roof pitch, I need to loosen this assembly first. So we'll come in here, release the ratchets, and take tension off the straps. And you can see how this block starts to drop away. Once it's loose, then we can change the roof pitch. Once we have the new pitch established, we'll hold that block in place, and then tighten down the ratchets on each side. A good way to do it is you kind of put your shoulder into it, so you can hold it flush with the top plate of the window, and then re-crank the ratchet back down until the strap is nice and tight. Okay, here's a close-up of the underside of the roof decks. To give you a reference point, this is the top of the window and the ratchet strap assembly with the spacer block. You can see how the straps are running through the 2 larger inside holes. I mentioned the 4 1/2-inch bolts that connect the roof decks together. So you got 1 bolt, and then down here, actually the C-clamps you see here are for that pallet brace, and that other bolt is just on the other side. The 3rd bolt down, and then the 4th bolt right near the base of the roof deck. Here again is the underside of the roof deck and a visual of the C-clamps that hold the pallet brace. These 2 sets are the ones on the left side of the roof deck, and this would be the 2 sets that are on the right side of the roof deck. Okay, here's a close-up of the base of the roof deck. This is what would be the soffit or eave line. You'll notice in the corner on this roof deck section, you have a corner brace and then 2 additional bolts that flank it. A mirror image on the same side, the other corner brace on the other roof deck, and the 2 bolts that flank it. Those 4 bolts that are adjacent to the corner braces support a deck brace, which further reinforces the base of the roof deck. Let's take a look at it from the outside. Here's a shot of the deck brace from the outside. It's a 3-foot piece of aluminum that's 1/8 inch thick. It's basically an angle brace that helps support the deck, almost acts like a shelf, and further reinforces the center joint. This is obviously a side shot of the bearing wall, which is comprised of 5 elements in itself. You have 2 4x4s, which are a little over 6.5 feet long. You have 2 triangle bases, which are 3 feet at the bottom and then taper to the width of the 4x4. And then you have what I call the front fascia plate, which is made out of 3/4 inch plywood. It's a little over 46 inches tall and 7 feet 7 inches wide. On the back side of the fascia plate are 3 2x6s that run laterally. One on the top, one near the middle, and one near the bottom, which add a little bit more rigidity to the front of the fascia plate and prevent some flexion when you're actually bailing off the roof and putting pressure against the wall. The triangle bases are connected to the 4x4s on each side with 2 3/8" bolts. The same as with the fascia plate. You have 2 3/8" bolts, one on the top, one on the bottom on each side that connected to the 4x4. The roof deck, when this pitch is set at a 12-12, is supported by this top fascia plate. For additional strength, we have 1/2" bolts that run through this 2x6 into the 4x4. Now the roof deck is adjustable to 3 different pitches. As I said, this is a 12-12 pitch, in essence a 45-degree angle. You can also adjust it to a 9-12 and a 6-12. Now to get an idea of what those roof pitches are like, the 6-12 for the most part is considered the first step, right at that transitional period of where you use a roof ladder or not. 5-12 and under is considered a walkable pitch. A 6-12, an experienced roofer can negotiate fairly safely. Experienced firefighters as well, but keep in mind that up here in Wisconsin, when we're working under snow and ice conditions, a 6-12 is where we're going to really start to consider using a roof ladder. Remember, the roof ladder not only aids in footing, but it also helps to distribute our body weight over a larger surface area. So when we're working with normal joist construction, not truss, but normal joist, the roof ladder would rest on the peak or the ridge board and then extend to the bearing wall, giving us 2 major areas of support if the roof deck would give way somewhere in between. So having this adjustable to a 6-12 allows us to still operate without a roof ladder and get a feel for what it's like, but also to plug in a roof ladder if we want to. A 9-12, you definitely want to use a roof ladder, and a 12-12 pitch is considered the steepest pitch that you can still safely use a roof ladder. Anything steeper than that, or again, obviously if you're dealing with truss construction, you're going to want to be operating from an aerial or the bucket of a tower ladder. So these are 3 different pitches that you can adjust the roof deck to. You could actually set it up for even a lower pitch than a 6-12 and almost go flat if you wanted to. You could keep these 4x4s 8 feet tall and really go with a flat roof deck, but we all know that that's pretty easy to operate on. So I set it for the 6, 9, and 12-12 pitches. This is an inside shot of the bearing wall. You can see the 2x6s that run laterally that add a little bit more rigidity to the outside fascia and prevent flexion of that section of the wall. Okay, you see the pallet brace inserted on the right side of the roof deck. Again, you can insert it on the left side, and a pallet will just rest on top of this and allow us to practice working with a saw either off of our right or off of our left. You notice that I have a ladder that I'm using. Let's take a closer look at that. Okay, this is the original ladder that's used in conjunction with the firefighter training wheel prop. It's 75 inches in length. It was taken from the top fly section of a 24-foot extension ladder that was damaged. Now, this is obviously the top portion of the fly. What we did to convert this straight ladder into a roof ladder was to add the same corner braces that we used to reinforce the decks to the base of the ladder. Now, these corner braces, they're 1 1/8 inch wide, 6 inches long, 1/8 inch thick, steel, extremely strong. They're connected to the base of the ladder with 3 machine screws on each side, along with lock nuts. Easily removable. Like in a minute, you can take them on or off. So if you don't want them on, take them off. You can use a ladder like you normally would. If you want to use it as a roof ladder, like I just showed you, you put these in place. And they're plenty strong enough. We've actually had 2 firefighters standing on this ladder when the deck's at a 12-on-12 pitch. So it works very, very well. This is our safety tether. It's a line that allows us to secure the base of the ladder. It's adjustable. This is a free end. It's a clove hitch with a safety. It's running through a 3/8 inch pilot hole that's 8 inches off the floor and 33 inches from each side of the fascia plate of the bearing wall. So there's a hole on the right and there's a hole on the left depending on how we want to set up our access ladder. Let's take a look at it from the inside. The rope is a section of 8mm cordage. It's running through a 2-inch steel washer and a barrel knot's tied on the other side. So there's no way that rope can be pulled through that 3/8 inch hole. So this acts as a stopper and allows you to adjust the tension on the rope when securing the base of the ladder. Hopefully that overview gave you a sense of the design and construction of the prop. Now let's take a look at how it can be used and the techniques that you can practice on.
The pitched roof is designed for a maximum of 2 firefighters to work on it at any given time, but you can see that it's strong enough to support the weight of twice that. When operating on a pitched roof without a roof ladder, always assess the area in front of you and avoid walking on the balls of your feet. The preferred method is to walk flat-footed. This will give you more traction in the event that a shingle would break loose. You wouldn't completely lose your footing. This technique is called the hand, foot, foot, hand method. Ladder transitions should be practiced going both up and down the ladder and should progress to carrying equipment. This method is sometimes referred to as using an axe the wrong way, but can be much more effective because you don't have to worry about the axe wedging into the roof. There are many methods for moving a ladder along a roof line. This technique is called a pivot and slide. Anytime you're operating on a pitched roof, it's important to move forward. This will help you to maintain situational awareness and your position on the roof at all times. Spiking is a technique performed to create a better foothold for the firefighter operating the saw. It can be used with a variety of tools, including a picket axe, the blade of a flathead, or the point of a Halligan bar. Ideally, the firefighter placing their foot should keep it flat on the roof surface. When practicing this technique, remember to check the setting and the depth guard before performing any cuts. This technique is performed only on the portion of the pallet that extends over the peak of the roof deck.
Okay, I'm going to take you through on how to set up the cutting pallet, which is a consumable that we use when we're practicing vertical ventilation on a pitched roof problem. Now the pallets that I like to use are the ones that have full dimensional lumber on the sides or on the ends, the ones without the slots for a forklift. This is especially important if you're going to be using the prop or the pallet for practicing rolling rafters. You're going to want a little bit of that additional mass instead of having those cutouts there. You're also going to need a sheet, 4x8 sheet of OSB. Now, 3/4 inch is your best, but you could go down to 1/2 inch if you wanted to. The easiest way is just to cut this down right in half, especially if you're just working with a 4x4 pallet. Your choice if you want to skin both sides. We like to do that. It just gives the pallet a little bit more mass, a little bit more padding, kind of a buffer when we're practicing spiking or working with the chainsaw to cut. It just gives us a little bit more distance. We don't have to worry about cutting through the pallet and into the roof prop. Tools that you're going to need or that we'll use, skill saw, pass load nail gun, a chalk, and then a hammer to finish off any nails. That's really all you're going to need for tools, and we'll show you how we do that. Line up your clean edges. Remember, it doesn't have to be perfect because you're just going to be cutting it up anyway.
This firefighter is demonstrating the technique for bailing off a pitched roof when no other means of egress is available. The anchor hook of their system is inserted into the roof deck in a simulated breach, and then the firefighter rappels off the side of the roof away from any extending fire. Here, multiple firefighters are practicing bailouts from 2 different locations simultaneously, both off the pitched roof and out the window. As stated earlier, it's important to understand that the pitched roof prop is designed for a maximum load of 2 firefighters operating on it at any given time. Even though these evolutions demonstrate that the prop can withstand the added weight, this is something that isn't advisable. Each one of these evolutions should be separated and practiced individually. Rocking and swaying of the prop is normal, especially when bailing off the pitched roof. For added safety though, 1 to 2 instructors should keep an eye on the stability of the prop at all times, especially near the bearing wall and any structural components. If any signs of compromise are noticed, the evolution should be stopped. This evolution simulates an unconscious firefighter trapped on a pitched roof, possibly due to a cardiac event. Here the rescuer is going to use their escape system to extract the firefighter off the roof. If the downed firefighter's SCBA is compromised and can't be used to attach to, one option the rescuer has is to use webbing to fasten a full-body hasty harness to the victim. Once the harness is secured, the next step is to use another section of webbing to create an anchor for the rescuer's escape system. Here the firefighter is using a 5-foot strap. This is wrapped around 1 to 2 rungs of the roof ladder and will be the primary anchor point for the rescuer's escape system. The descent control device of the rescuer's escape system is attached to the anchor strap, while the anchor end of the escape system is attached to the victim's hasty harness. When both ends are secure, if the victim has an escape system, it can be used to assist with pulling the victim off the roof. One end is tossed to rescuers on the ground, while the other end is secured to the victim's ankles, preferably using a girth hitch. With both ends of the second system secured, the rescuer will lower the victim off the roof while firefighters on the ground assist.